Hey. All right. How's it going, guys? This is Mac and Cheese. I'm Cheese.
I'm Mac.
He's Mac. In the right direction. We are talking today about how to move fast and not break things, integrating Terraform, Kubernetes, and CICD. So we do these webinars some number of Tuesdays. So you'll be seeing more of them online. Let's jump right into it. So what are we actually going to learn today? And actually, incidentally, next week, because this turned out to be long, so it's going to be a two-parter. But in part one, stick around if you want to learn about what you actually need to do in order to run Kubernetes on multiple clouds. We're going to talk through how to evaluate different infrastructure as code providers to set up Kubernetes on multiple clouds. And then next week, we're going to be digging really into, as you think about your infrastructure and your code and your different deployment models for those, how do you dig into the distinctions of what should deploy when? But starting off today, what are we going to talk about? So to start off, we offer value to the company by providing specifically invariants to the actual Ascent development team. We are not usually shipping most business logic features. We are typically supporting people who are doing that. One of the ways in which we do that is we provide Kubernetes as our core development infrastructure, development and production. It gives you a shared API for runtime, but you do actually need to get it launched. And that's what we're really going through today. As it turns out, Terraform is really great for setting up Kubernetes, but it has a number of pain points that will impact what else you want to actually configure with it, whether it is just Kubernetes, just your network, or some more than that. Getting into it though, what do we do at Ascent? So Mac and I work at Ascent. We do infrastructure, and we provide value in a couple ways. One is actual commoditization of the product. So we need to make the product into a shippable commodity. That part of that is running everywhere. So we run in 3 clouds: Azure, Amazon, and GCP. That means that we have a very large addressable audience for our product. Simplest way to actually expand your target market, run more places. Next part, running securely. If you go into a conversation with enterprise sales and you cannot pass their security questions, they will not buy your product. It doesn't matter how much the actual development team likes your product. If they can't get past security, you can't either. And finally, launch easily. So we can now today launch on any of the 3 clouds we support in about an hour or less, depending on customer versus in-house environment. It's pretty good, frankly. It wasn't always that easy.
Yeah. I can't emphasize the run anywhere enough. I think that is a major target of ours.
Yeah, it's a very straightforward way to add value. But the second big part of what we actually do is we make the Ascent infrastructure very easy to run on. So what goes into that? We provide this shared API through Kubernetes as the actual deployment target of our developers. So they don't need to largely think about what cloud they're running on. They pretty much just write Kubernetes manifests, ship the code, and mess with some config, and they're off the races. We also, and this is really what gets into the meta that supports that, is we establish and ensure invariance in the infrastructure. So what we provide is no matter what, in an Ascend environment, you will have 2 Kubernetes clusters. You will have, blob storage. You will have MySQL databases. There is some set of things that we need to make guarantees about in order for development to move smoothly. So they can just say, yes, I would like to call upon the address of our egress IPs because I need to display that right now. And it's available.
It's a lot easier when our developers don't have to worry about doing things like turning machines on or machine counts.
Exactly, and they can get just state of the work of the actual business logic and building the best data platform in the world. So how do we run Kubernetes in 3 clouds, though? It's not trivial. What about kops? Any of you who have looked into launching Kubernetes on, particularly Amazon and GCP, kops comes up in those conversations pretty immediately. We actually used to use it for Amazon. It doesn't solve the complete picture for us. First big thing, it doesn't handle non-Kubernetes components. So when we have portions of our infrastructure like our blob storage buckets, S3, our MySQL DBs, it doesn't handle those. So no matter what we did, we had to have kops actually interact with our Terraform. And we ended up running into a lot of pain points there because ultimately kops doesn't like sharing state with other systems. Kops and Terraform each like to think of themselves as the source of truth in the world. And when you try to mesh them together, it's operationally more complicated. And you don't need more complications in this environment. Moving a little further, though, running Kubernetes at low cost is relatively hard. Running it cheaply, if it's fairly static, you could do that. Making it stable is not all that hard, but making it scalable and stable and cheap, that's a challenge. And that's not something that we specialize in. It's not valuable for us to specialize in it. So kops kind of force you into that question. We don't think it's a very good option for our need, particularly because of the highly scaling nature of our clusters.
Yeah, if you look at the operational overhead of manually rolling Kubernetes clusters alone, it turns out to be a way more than any of the control plane costs for the clouds.
Exactly, and you don't want to be paying your engineers to figure out how to run Kubernetes when there's someone else who you can pay for cheaper. And there are a few options actually that you could look into that way. One is there are a number of providers like Anthos, Docker, Spectro Cloud, OpenShift, who can run Kubernetes across multiple clouds, and you could pay them to operate your clusters. The main problem is it's obscenely expensive. And part of this, again, is a characteristic of we run a relatively large number of nodes with a relatively large number of CPUs, and when you're looking at $500 to $1,200 per CPU per year for these solutions, I can't make that ROI work. It just doesn't make any sense. I'm sure it's delightful, and I'm sure that there are people for whom that's a really great cost benefit, but we're not one of them. Everyone has cost constraints. This is not a good place for us to spend our money. And at the end of the day, it actually still doesn't solve your non-K8s infra problem. You still need to spin up databases and buckets, and manage your external IPs and all that. There are some pieces outside there. So what we actually ended up going with, particularly because we had a great experience with GKE fairly early on, is just pay your cloud provider to run it for you. these solutions have been transitioning from free to paid, so they're not as cost efficient as they used to be. But you're still looking at $876 per cluster per year, which is a pretty banging deal. We have still had some pain points with them, some availability problems, some differences just between providers, but this is a really great ROI for us, based purely on simplicity, and reduced work for our the infrastructure team. But you still got to plug into the rest of your resources, and this is where we think that infrastructure as code really fits nicely. You got to run a bunch of resources, make it consistent, make it templatable, pluggable, and that's IIC. It's that simple. So infrastructure as code. Terraform, yeah. I mean, yeah. Effectively, yes. As it happens, there are other solutions in the infrastructure as code space. The biggest limiter for us is that we are multi-cloud, and that immediately, off the bat, limits us basically down to Terraform and Pulumi. Terraform existed before Pulumi. It had more market share. It's more mature. Pulumi is different from Terraform in that you can write actual code, which means that you can take advantage of a lot of IDE features, just linting, what have you. Basic logic becomes a much easier thing to implement, which is very hard in HCL in Terraform. But it's relatively recent that Pulumi has had things like full Golang support, which we really wanted before using it. And at this point, we still need to figure out, are there things to shift over onto it, and is that a valuable thing to do right now? But outside of that, there's no other real big competitors. CloudFormation, Azure Resource Manager, Google Deployment Manager, they're not cross-cloud. Can you, strictly speaking, convince them to deploy resources on another cloud? Yes. The way that you would do that in CloudFormation is with a Lambda. But at that point, you're writing your own providers, and there's better ways. So is Terraform good? It may be the only option, but is it good? It's okay. It's not bad enough. So it does have problems. State management is one of the big ones. There's still issues with if you have a resource that has a count on it, and then you refactor it to not have a count, from 0 to 0 resources or 1 to 1 resource, it blows up in your face. It doesn't know how it breaks, and you need to go fix the state. It's painful, but you don't necessarily need to run into this if you're writing your own modules. We happen to run into this because I pulled in a bunch of open source modules and was refactoring them to better fit our needs. So your mileage may vary. Another bit of this is there's config and plain text in the back end. This generally doesn't matter because usually your state is a description of a bunch of machines, network site arranges. It's usually not sensitive, but some resources are credentials. And Terraform itself, without potentially, I think, using the Vault plugin, doesn't know how to do anything with that. It doesn't know how to encrypt secrets in its own back end. So it doesn't. There are some providers that have solutions for this, like the Amazon provider. You can provide a public PGP key. Yeah. And I think that's delightful. I think it's a great solution because then you have an encrypted value there and you can pull it out and decrypt it elsewhere without having to, have it sitting around and plain text in the bucket. So you need to protect your bucket as though it is a secret store, even though strictly speaking, it's not exactly a secret store. And following all this, Terraform creation is very easy. Terraform destroy is very hard. And this is a side effect of, in a lot of cases, Terraform isn't fully aware of all the resources it's impacting, because some resources have side effects. And we'll dig into that a little bit more later. But what it means in effect is the full automation of Terraform workflows becomes challenging because you have to figure out how to convince Terraform to do the right thing. And
yeah, you end up on the other side with the providers, and during provisioning time, things get turned on. Terraform's not in control of it all. So definitely on delete, you have to unwind some stuff.
Exactly, because you have these hidden dependencies that Terraform just doesn't know exist. But at the end of the day, a lot of that actually comes down to the providers themselves. So, like as I mentioned, little things like the Amazon provider having the ability to support a public PGP key to encrypt the secrets in the back end, that's fantastic. But only Amazon does that, as far as I'm aware. It would be really useful to have that be a native feature of Terraform, or for it to, be supported more broadly. But what you end up running into is the way Terraform actually works is Terraform is this core engine, and people build providers off of that as modules to basically plug into their own interfaces. But it's not a bunch of HashiCorp people building all of those. It's people from the various cloud vendors, from other products, who are building each of those. And they don't, there is no consensus on style or expected behaviors, or even really best practices in building those providers. So you end up with what looks like a hodgepodge of, built by people with entirely different goals, providers, because it is. It's exactly what it is.
When you look at Terraform providers, you start to look at exported attributes and outputs to really understand how to operate the product.
Yeah, and you end up, we recently started hacking around the AKS providers to convince it to support spot pools, because you can't actually create them with Terraform, but you can manage them with Terraform, apparently. But we had to, kind of trick it. So it's a bit of a quirk, and this is a lot of what you see with Terraform problems. Is they're not strictly speaking Terraform problems. It's Terraform has to be the API for everything, so that's hard. So through all this, obviously we decided to use Terraform because at the timing and given our needs, it was the best fit. Arguably, it was the only fit for a tool that would actually do that. But you're starting a project tomorrow. First, good luck. Have fun. But what actually should you use? So this may look like a lot of information. It's actually relatively simple. There is a classical tool set of your, all of your sort of, VM provisioners, your Chef, your Puppet, your Ansible, all these things that are supposed to do config management at an actual virtualization level. These are perfectly fine tools, but what we've really found is that they don't have any particular relevance to a purely Kubernetes stack. Particularly when you're using managed providers, we pretty much just let the providers manage our operating systems and our machine images for us. We use those, and then we don't have any need for Chef, Puppet, or Ansible, because the rest of everything they do is managed by Kubernetes. We don't need them. So we actually think at the cloud resource level. We don't think about VM management. We think about managing cloud accounts, clusters, node pools, higher level abstractions. When you do get into that layer, you're basically looking at, best we can tell, Terraform, Pulumi, and then your cloud-specific providers.
Right.
The first thing to look at here is, do you need to be multi-cloud? A lot of people don't. You can run on one cloud and that's fine. There's nothing wrong with that. If you are running on one cloud, take a look at the provider for your cloud. There are nice features like, in CloudFormation, if a stack deploy fails, CloudFormation actually knows how to roll back that deploy. Terraform does not do that. That is not a thing. So you can get advantages, little things like the moment that any resource is added to Amazon, it is supported in CloudFormation, guaranteed. We see feature releases pretty much constantly from the clouds where we have to wait for provider support to show up in Terraform.
Or at deploy time, if you're having an issue, it might be time to check your provider versions.
Exactly. You might be running an old provider. There might be features that you don't know you can access yet because managing those is hard. But like there are real advantages to be had from using your cloud's management plane. Once you actually get to the point of being multi-cloud, though, you're pretty much looking at Terraform and Pulumi. Terraform is more ubiquitous. If you are trying to do something super quick, where you're launching a handful of resources and not like a fairly static environment, Terraform's actually really good for that because you're just describing the resources that you need, you write them up, you template in your config, and you run it. Pulumi, the first threshold you're going to have is setting up your environment for Terraform is pretty easy because you basically brew install Terraform, write some config, you can even use local state and then just apply it. Pulumi, let's say you want to use Go. You need to set up your Go dev environment. There is actually a number of steps that go into that. There's just a little bit more to get going, but once you want to do anything remotely complicated, check out Pulumi, try it out. It's got a lot more functionality just purely on the basis of it's using code rather than HCL. HCL is a very limited templating language. It's fine, it works, but there's a lot of pretty basic logic that you would like to, in many cases, describe that's hard to do in HCL.
I think an important thing to look at here is to understand the project needs and to really look at trying to keep your templating system KISS, keep it simple, stupid. And the tool almost picks itself for you.
Right. But rolling on, we chose Terraform. Terraform seems like kind of a pain. It is. In certain ways, it isn't. I mean, we have a single tool with a simple interface to manage infrastructure across 3 clouds. That's not bad. I'm okay with that. But really, when you dig down into it, Terraform is about as hard to run as your most painful resource. In a lot of cases, what that is a managed service. And this is an artifact of the actual APIs of the cloud providers. So, for example, you launch an AKS cluster, you're going to get a hidden egress IP that they won't really tell you about. If, like us, you need to expose your egress IPs to the customer so that they can whitelist them so that we can get to your data sources, it's relevant for us to know what that egress IP is. But because there's no consensus on, like what should actually get returned by these resources, that, hey, all these things you create in the background, you should expose them as knowable config. So there's some amount of hacking around that to just figure out what they are, or find another way to create the resource ahead of time and tell the service to depend on it. But this all, the other side of this is the resources that you don't know about, Terraform doesn't know to manage. So this gets back to the deletion problem, where you can end up in these weird situations where you can't complete a deletion because some resource Terraform wants to destroy is locked up by some resource that Terraform doesn't know exists, that got orphaned because the managed service deploy didn't happen in exactly the right order, or missed the cleanup, or something.
If you have a resource that has an attribute that can change, it makes it really interesting, like an egress IP. So you have to watch those kinds of things.
Yeah, and Terraform works really well when it can own the whole state of the world, and managed services just make that harder. And frankly, we use managed services all over the place, because, like I said earlier, they're great. You pay Amazon, you pay Google to be good at something for you at a reasonable rate, and they take care of it. They're also on the hook for support. You call them and say, hey, this is broken. They're like, great, cool, I'll get on that. So it's a devil's deal. This is the trade-off. But at the end of all this, the result really is that Terraform is what amounts to a slow tool for us. Because there's all these things that it's painful to interact with Terraform that get pulled in, like the complexities of these managed services. It's difficult to run Terraform very frequently, and we therefore tend to run it less frequently. We tend to create things that don't change very often, with the intent that they are relatively static. And this is actually where we're going to leave off for today. As we said, we provide value by creating invariants for our development team, and by shipping our environments to anywhere in the world securely, consistently. We use Terraform. We use infrastructure as code through Terraform to run Kubernetes on multiple clouds. We chose Terraform. We think there are other options. Depending on your needs, you may choose something different. But Terraform's what we're running with. Next week, we're going to dig a little bit deeper into what we really mean by slow. What are all the things you need to think about around something that is a slow deployment? We're going to get into the flip side. What is fast tooling? If Terraform is our slow release mechanism, what is our fast release mechanism, and what is that good for? And specifically, as you think about the actual resources and configuration that you need to deploy, what works well to release slow versus fast? So I hope you all enjoyed it. We are actually going to be doing another webinar next week. We normally do these bi-weekly, but we'll see you then.
See you next week.